Today we are going to learn to solve rational equations. We've done a little bit of this, but we're going to do a little bit more. So let's start out today by doing these warm-up questions. Go ahead and pause the video and work through these 4 warm-up questions. Now that you've worked through these 4 questions, let's go ahead and uncover them to see how you did answer-wise. On the first question, this is what we have. So you just realize that the LCM was 2x squared times the quantity 2x minus 1. On the second one, after you factored it, this was your LCM. Okay? Now, third and fourth, you add and subtract it here by finding the common denominator. Here's what you should have gotten. Okay, now that we've reviewed a little bit, let's go ahead and begin the lesson for today. There are 3 new vocabulary words that we need to look at today. First one here is a rational equation, which we're going to define in a few moments. And sometimes when we solve equations, we're going to come up with what's called an extraneous solution. And then lastly, we're going to be looking at rational inequalities. Let's begin here today by writing down our first vocab word, a rational equation. And a rational equation is an equation that contains one or more rational expressions. Now, let's give you an example of what a rational expression is going to be. A rational expression, let's say that I give you a polynomial, say x plus a 2, over top of, say, x squared plus a 3x plus a 4, and then I were to give you another rational expression on the other side, and it could be something like, say, x minus 3 divided by, say, x plus a 4. Now, notice I have a rational expression on the left, a rational expression on the right. When I put that equal sign in the middle of them, it becomes a rational equation. In this slide, we're going to look at how we're going to solve for rational equations. In solving rational equations, we want to find the LCM. Okay, we want to find the LCM. We're going to take that LCM, it becomes our common denominator, our least common denominator, and we're going to multiply each term of the equation by that least common denominator. Now, when we're all done solving it, then we're going to plug it back in, and that's very important. We're going to plug it back in to make sure it's not extraneous. And that's one of our vocabulary words for today. What is extraneous? Extraneous solution is a solution of an equation derived from an original equation that is not a solution of the original. In other words, we plug it back in and it doesn't work. Let's go ahead and take a look at our first problem here today. First of all, look at this and ask yourself, what is the LCM here in this problem? Well, remember here, underneath here is a 1, underneath here is a 1. So what's the common denominator, or the LCM, between 1 and x? Well, it's going to be x. So we are going to multiply every term in this equation by x. So let's go ahead and do that. So I multiply this term by x, oops, multiply this term by x, multiply that term by x, and multiply that term by x. Now, when we multiply it by x, notice what happens right here. X times x gives us, yes, x squared. Notice what happens here. When I take this x, this 18 over x times this x, these two x divide out. So this divides out like that, and I no longer have a denominator. And then over here I get 3 times x, so it looks like this. So x squared minus 18 equals 3x. Now, at this point, I can look here and I can see it is a quadratic equation. How do we solve quadratic equations? Well, notice I have a linear term, so I need to get everything to one side. So let's go ahead and subtract 3x to both sides. It's going to look like that. Now, I have a quadratic equation. Can I factor it? Well, yep, we sure can. So what factors of negative 18 are going to give me negative 3? All right, so it's going to be x minus a 6, x plus a 3. Then we're going to use the zero product property, and we're going to set 3 minus x equals to 0. And we're going to set x plus a 3 equals to a 0 and solve for each. And we will get x is equal to a 6 and x is equal to a 3. Now, make sure you check for extraneous solutions. So we're going to plug it in to see if they both work. And notice here, 3 does equal 3, so that one checks. And 3 does equal 3 in this case, and that one checks as well. Okay, I want you to work through this problem here. So, first of all, go ahead and pause it. And remember, you're finding the least common multiple, which becomes our common denominator, and that's what you're going to multiply each term by. So find the LCM first. Okay, now that you've done this, what did you find for your LCM? Well, let's go ahead and take a look at what you did find. First of all, look in here, I had a 3. I have an x, and I don't see anything underneath there, so hopefully you remembered there was a 1 underneath there. Okay, so what is the common denominator between a 3x and 1? If you had 3x, you are correct. So that means I'm going to multiply each term by 3x. And in multiplying each term by 3x, by doing that, we're going to see that things divide out. Notice, this 3 here divides out with that 3, leaving us with a 10x on the left side. This x divides out with this x, leaving me with a 12 in this area. And then, of course, we just multiply the 2 times the 3x. So when I'm all done, it gives me a 10x is equal to a 12 plus a 6x. Now, notice here, I just have 10x. I have a 12 plus a 6x here, so I need to subtract this 6x to both sides, giving me a 4x. 4x equals 12. Divide both sides by 4, and I get x equals 3. Now, make sure you check it to find out if it works. So, you're going to take this, and you're going to plug in that 3 in for x right there. So, plug in a 3 right there, so you have 10 thirds. Does that equal 4 thirds plus 2 over 1? Well, let's see. This gives me 6 over 3. And adding that together, that gives me 10 thirds. So, yep, it checks. And remember, since you solved it, and it did work, put your answer in Set Builder notation. Once again, go ahead and pause this and work through this question. Alright, now, in looking at this, what did you find for the LCM? Well, let's see. I have an x, I have a 4. So the least common multiple is going to be 4x. So that means, what did I multiply each term by? You said it, 4x. So I multiply 4x here, 4x there, and 4x there. Now, look to see if things divide out. In this first situation, what divides out here? Well, I see an x down here. Is there an x up here? You betcha there is. So this divides out with this, leaving me with a 24 in that spot. Okay, so let's look at the next one here. Over here you see that this 4 divides out with this, leaving us with, in this area, 5x. And then of course over here, I see this 4 divides out with that 4, leaving me with a negative 7x. Now all that I have to do is get this 5x to the other side, and in doing so, it looks like this. So 24 equals negative 12x. We're going to divide both sides by negative 12, and I will get x equals negative 2 for my answers. Now again, make sure it works. So you're going to take that negative 2 right there, simplify that, and let's see, you have 6 divided by negative 2, which is a negative 3. Alright, so let's go down here and check it. We have negative 3 plus 5 over 4. Does that equal negative 7/4? So let's see, what's my common denominator? Well, I'm going to multiply here by 4 over 4, gives me negative 12 over 4 plus 5 over 4. And 12 minus 5 is negative 7/4, so guess what I just found? It works. So that means this solution is the solution for this rational equation. Sometimes our problems look like this one here. Notice in looking at this one, I have 5x over x minus 2. So now I have a binomial in the bottom. So look here and ask yourself, all right, what is my common denominator between x minus 2 and x minus 2? Well, x minus 2, you say. I agree. So what we're going to do is we're going to multiply everything by that common denominator, x minus 2. So we're going to multiply this side by x minus 2. Going to multiply this side by x minus 2. Now, will anything divide out? Well, I have an x minus 2 down here. And I have one up there, so yes, this divides out with this. Likewise, this one divides out with this one. And it leaves me with a 5x here equaling a 3x plus a 4. Alright, so we have 5x equals 3x plus 4. Right here I'm going to subtract 3x to both sides. And in doing so, that gives me 2x equals a 4. Divide both sides by 2 and I get x equals 2. Alright, now, does that work? Well, if you take that 2 and you're going to plug that 2 right here, I get 2 minus 2 gives me 0 in the denominator. That tells me right there I have an extraneous solution. Why? Well, you tell me why. Yes, you're right. We cannot divide by 0. So that means I have an extraneous solution. And what is my solution? Well, my solution is going to be the empty set. Or you could say no solution. Let's go ahead and try this example now. Pause it for a moment and I'll let you go ahead and work it through and then we'll work it through together. Alright, now that you've worked it through, let's take a look and see what you came up with. First of all, the common denominator is what? Well, 2 times the quantity, x minus 8. Yes, so we multiplied that in each situation. Now, after we do that, we see that, well, let's see, x minus 8, that divides out. 2 and the 2 divides out. X minus 8 divides out. Okay, so it looks something like this. Now, after those divide out, I'm left with this right here. Now, what do I do here? Well, let's see, I need to get rid of parentheses. So I'm going to distribute the 2 inside, distribute the x inside, multiply this 11 and 2 together. So that's going to get me this. Now, am I finished? No, because what do I see right here? Yes, like terms. So that's going to give me, let's put this in descending order, so it gives me x squared minus a 4x minus a 10 equals 22. Now, what do we do next? Well, if you said set it equal to 0, I agree. So it's going to be x squared minus a 4x. Now, how do I set it equal to 0? Subtract 22. Yes, I agree again. So that's going to be minus 32 equals a 0. Now, I have to figure out what factors of negative 32 will give me negative 4. Well, hopefully you can look at that and you can see, well, it's going to have to be x minus 8 and x plus a 4. And that is set equal to 0. Okay, so now I'm going to set each of those equal to 0. And I get x is equal to an 8. And I get x is equal to a negative 4. Now, will they work? Well, let's see. If I plug a negative 8 or a positive 8 right there, the denominator goes to 0. So that tells me right off the bat, what about 8? Well, it's extraneous, so it's out the door. Will not work. Now let's plug a negative 4. I'm going to plug that negative 4 here, plug that negative 4 there, plug that negative 4 there, plug that negative 4 there. And what do I get here? Let's see here. I'm going to get, looks like negative 13 over negative 12. And then I have negative 4 over 2. I need to get a common denominator. So if I get a common denominator, that's going to give me a negative 24 over 2. Okay, and on the other side, that's going to give me 11 over negative 12. All right, now these two negatives make a positive. 13 minus 12 gives you a negative 11 over 12, which gives me negative 11 over 12. And guess what? That is a true statement. So let's put this in set builder notation. All right, let's see if our slide agrees with this. Yes, it does. It says the solution, x equals 8, is extraneous. So our only solution is x equals negative 4. Okay, folks, this wraps it up for today. Please write down this problem set. Also, make sure you write your summary in your Cornell notes, and have a good day, and we'll see you next class.